Hey, 8th grade. So today we're going to start talking about space. So we were talking about physics and different things within physics. And today we're going to move on to our next unit, which is space. So our focus question for today is going to be, how do the relative motion and relative position of the sun, earth, and moon affect the seasons, phases of the moon, eclipses, and tides? So let's first start by talking about Earth's movements. Earth moves in space in two major ways: rotation and revolution. Rotation is the spinning of the Earth on its axes, and this is an imaginary line that passes through the Earth's center and the North and South poles. Rotation is the reason that we have day and night. It takes 24 hours for the Earth to rotate once around its axes. So, one full rotation of the Earth takes 1 day or 24 hours. Now, you'll notice that Earth is actually tilted and does not rotate straight up and down. And this will make more sense as to why when we continue with this lesson and through next week. So you have this incoming solar radiation. The Earth is tilted as it rotates around, creating day and night. Revolutions is when the Earth travels around the sun. So you have the sun in the middle and the Earth traveling around it with the moon spinning around the Earth. Revolution is the movement of one object around another. And one revolution of Earth around the sun is called a year, and it takes 365 days. So when you think about this revolution, um, think think about the seasons of the Earth. So near the equator, the sunlight hits the Earth directly. Near the poles, the sunlight arrives at an angle. And this difference in direct and indirect sunlight leads to really big differences in temperature from place to place. This is why the more tropical you go or towards the equator, the warmer it is, and the more towards the poles or the temperate regions, the cooler it is. And this has to do with the Earth's tilt and its revolutions. So, if you watch this video real quick, you'll notice as the Earth revolves around the Earth as it's rotating, different parts of the Earth, the northern and the southern hemisphere, tend to have more or less indirect and direct sunlight. If the southern hemisphere has more indirect or direct sunlight, it would be summer. If it has less, it would be winter. And the same for the northern. If Earth's axes were actually straight up and down, the relative to its orbit, temperatures in an area would remain constant throughout the year and there actually would be no seasons. So Earth has seasons because its axis is tilted as it revolves around the sun. So once again here you'll see as it's tilted, it revolves around the sun. You have spring, summer, solstice, fall equinox, and the winter solstice. So basically, what this means is that between December and March, we have winter. Between March and June, we have spring based on the relative position of the Earth compared to the sun. From June to September is summer, and September to December is fall or autumn. And if you'll notice on this, we have this red circle. This is showing the Arctic Circle with the North Pole is that little yellow. So during different parts of the seasons, you have different direct sunlight hitting different areas of the Earth. Go ahead and watch this quick video. Shows you where the sunlight's hitting as the Earth rotates. So notice that during different hemispheres, the seasons are different, and as 6 months later, they then reverse. Anything that rotates around the sun has a season. We'll watch it one more time. Notice that in the northern hemisphere, it's winter because it's tilting away. In the southern, it's summer because it's closer to that sunlight. 6 months later, that reverses. The more direct part is the northern hemisphere, which is summer, and the further part is winter. Go ahead and move on to the rest of your work in your packet. Once you complete that, you may be on Quizlet.